Lesson. Exponential equations. Our intuition about the future is linear, but the reality of information technology is exponential, and that makes a profound difference. If I take 30 steps linearly, I get 30. If I take 30 steps exponentially, I get to 1 billion. Ray Kurzweil. Procedures to solve exponential equations. First, create the same base and exponent. So you can either make base or exponent or base and exponent. 2. Use U substitution or inverse operations, or U substitution and inverse operations. Solve the following exponential equations. Question 1. 4 raised to the power 2x minus 3 equals 8 times 2 raised to the power x minus 3. On the domain, the set of real numbers. This is an exponential equation because the bases 4 and 2 are constants. The variable x occurs in the exponents. The prime factorization of 4 is equal to 2 squared. And the prime factorization of 8 is equal to 2 cubed. Replace 4 and 8 by their prime factorizations, equivalent to 2 squared, everything to the 2x minus 3, equals 2 to the third, times 2 to the x minus 3. We created the same base using prime factorization. Use the power property for exponents. Power to power. Keep the base and multiply the exponents. To multiply powers of the same base, keep the base, add the exponents. So in our equation, we get equivalent to 2 raised to the power 2 times the quantity 2x minus 3 equals 2 raised to the power 3 plus x minus 3. Perform calculations, eliminating parentheses and applying the distributive property of multiplication over addition. Equivalent to 2 to the power 4x minus 6, canceling like terms, equals 2 to the power x. The exponential function is a one-to-one function, which means f of x1 equals f of x2 is equivalent to x1 equals x2. Let the function f be f of x equals 2 raised to the power x. F of 4x minus 6 equals f of x. We can remove the function without losing or gaining solutions. Equivalent to 4x minus 6 equals x, which is equivalent to 3x equals 6, divide both sides by 3, which is equivalent to x equals 2, which belongs to our domain. The set of solutions is equal to the set made of 2. Question 2. 3 raised to the power x squared plus 5 over 27 raised to the power 2x is equal to 1 over 3 raised to the power x plus 1 on the domain of the set of real numbers. This is an exponential equation because the bases 3 and 27 are constants. The variable x occurs in the exponents. Our goal is to create the same base. This is also a proportion. Use the cross product property of a proportion. The product of the extremes, which are the outer terms circled in purple, is equal to the product of the means, the middle terms circled in blue, which is equivalent to 3 raised to the power x squared plus 5 times 3 raised to the power x plus 1 is equal to 27 raised to the power 2x. Use the product property for exponents, so to multiply powers of the same base, we keep the same base, which in this instance is 3, and we add the exponents in red. Equivalent to 3 to the power x squared plus x plus 6 is equal to, replacing 27 by its prime factorization, 3 cubed, everything raised to the power 2x. Using the power property for exponents, where power to power is done by keeping the base, 3, and multiplying the exponents, 3 and 2x. Equivalent to 3 raised to the power x squared plus x plus 6 equals 3 to the 6x. The exponential function is a one-to-one function, and as we know, f of x1 equals f of x2 is equivalent to x1 equals x2, which is equivalent to x squared plus x plus 6 equals 6x. After writing the quadratic equation in standard form, by adding negative 6x on both sides of the equation, equivalent to x squared minus 5x plus 6 equals 0. And now we use the guess and check technique to factor the trinomial, which is equivalent to the quantity x minus 2 times the quantity x minus 3 equals 0. Employing the zero product property, x1 is equal to 2, which belongs to our domain, and x2 is equal to 3, which also belongs to our domain. The set of solutions is thus the set made of 2 and 3. Question 3. The cubic root of 32 raised to the power x, everything over 2 raised to the power x plus 2, everything raised to the power x minus 2 is equal to 1. The domain is the set of real numbers. And this is an exponential equation because the bases 2 and 32 are constants, and the variable x occurs in the exponents. Our goal is to create the same base. If a fraction is equal to 1, then the numerator equals the denominator, and both of them are non-zero. So this is equivalent to the cubic root of 32 raised to the power x is equal to 2 raised to the power x plus 2, everything raised to the power x minus 2. Write the radical as a fractional exponent. To write a radical as a fractional exponent, the power to which the base is raised becomes the numerator, and the index of the radical becomes the denominator. In this case, the index is 3, and the power is x, which results in the equivalent 32 raised to the power x over 3. Now on the right side, we use the power property for exponents, which we remember as being power to power is keeping the base of 2 and multiplying the exponents in blue and red. So we have equals 2 raised to the power the quantity x plus 2 times the quantity x minus 2. We want to replace 32 by its prime factorization, which is equivalent to 2 to the 5th, everything raised to x over 3. And then on the right side, we'll perform calculations in the exponents using the difference of squares formula. So equals 2 raised to the power x squared minus 4. Then we use the power property for exponents, keep the base, multiply the exponents. Equivalent to 2 raised to the power 5x, everything over 3, equals 2 raised to the power x squared minus 4. The exponential function is a one-to-one function, which means f of x1 equals f of x2 is equivalent to x1 equals x2. And if we let the exponential function f be f of x equals 2 raised to the power x, the left side can be represented as f of 5x over 3, which is equal to the right of f of x squared minus 4. We can remove the function without losing or gaining any solutions. So thus, this is equivalent to 5x over 3 equals x squared minus 4. Eliminating denominators, by multiplying both sides of the equation by 3, we obtain equivalent 3x squared minus 12 equals 5x. This is a quadratic equation. Let's write it in standard form by adding negative 5x on both sides of the equation. Equivalent to 3x squared minus 5x minus 12 equals 0. To solve it, we can factor the trinomial using the break and group method. So to do that, we find the sum, which is negative 5, the product, which is negative 36, and the factors of 36, which are as follows: 1 and 36, 2 and 18, 3 and 12, 4 and 9, and finally 6 and 6. The pair that adds up to negative 5 and multiplies to negative 36 is positive 4 and negative 9. We will rewrite negative 5x as equivalent 3x squared minus 9x plus 4x minus 12 equals 0. Now we can group the first two terms and factor the GCF, which is 3x, equivalent to 3x times the quantity x minus 3. Then we group the next two terms and factor the GCF of 4, plus 4 times the quantity x minus 3 equals 0. Factoring the GCF of x minus 3, equivalent to the quantity x minus 3 times the quantity 3x plus 4 equals 0. Utilizing the zero product property, x1 is equal to 3, and x2 is equal to negative 4 over 3. Both roots are in the domain, thus the set of solutions is equal to the set made of negative 4 over 3 and 3. Question 4. The square root of 3 times the square root of 3 raised to the power negative x plus 2 is equal to 1 over 243 raised to the power 2x plus 5. The domain is the set of real numbers, and this is an exponential equation because the bases 3 and 243 are constants, and the variable x occurs in the exponents. Our goal is to create the same base. Replace the radical by a fractional exponent. To write a radical as a fractional exponent, the power to which the base is raised becomes the numerator, and the index of the radical becomes the denominator. Replace the square root in the fractional exponent by 1/2. Bring down 3. Replace the square root by fractional exponent 1/2 again. And then copy the quantity under that final radical, which is 3 raised to the power negative x plus 2. Replace 243 by its prime factorization, so we have equals 1 over 3 to the 5th, everything raised to the power 2x plus 5. And then we utilize the power property for exponents, keep the base, multiply the exponents. Equivalent to 3 times 3 raised to the power negative x plus 2, everything over 2, and then the entire quantity to the 1/2 equals 1 over 3 raised to the power 10x plus 25. Then we use the product property for exponents, and to multiply powers of the same base, we keep the base, add the exponents. So on the left-hand side, we obtain 3 raised to the power 1 plus negative x plus 2, everything over 2, the entire quantity raised to the power 1/2. And then by applying the definition of negative exponents, we obtain on the right-hand side 3 raised to the power negative 10x minus 25. Bringing to the same denominator and adding, equivalent to the quantity 3 to the power 4 minus x, everything over 2, raised to the power 1/2 equals 3 raised to the power negative 10x minus 25. Using the power property for exponents, keep the base, multiply the exponents. Equivalent to 3 raised to the power 4 minus x, everything over 4, equals 3 raised to the power negative 10x minus 25. Consider the exponential function f, where f of x is equal to 3 to the x. The left-hand side can then be rewritten as f of 4 minus x everything over 4, which is equal to the right-hand side of f of negative 10x negative 25. We can remove the function f without losing or gaining solutions. Equivalent to 4 minus x everything over 4 equals negative 10x minus 25. This is a linear equation. Eliminate the denominator by multiplying both sides of the equation by 4. Equivalent to 4 minus x equals negative 40x minus 100. Separate the variable. Add positive 40x and negative 4 on both sides of the equation. Equivalent to negative x plus 40x equals negative 100 minus 4. Performing calculations. Equivalent to 39x equals negative 104. Divide both sides by 39. Equivalent to x equals negative 104 over 39. Let's reduce the fraction by the GCF of 13. Equivalent to x equals negative 8 over 3, which belongs to the domain. Thus, the set of solutions is the set made up of negative 8 over 3. Question 5. 6 raised to the power x plus 1 plus 6 raised to the power x minus 1 plus 6 raised to the power x equals 43 divided by 6 raised to the power x minus 2. The domain is the set of real numbers. And this is an exponential equation because the base 6 is a constant and the variable occurs in the power. All the bases are the same, so our goal is to create the same exponent. Let's eliminate the denominator. Multiply both sides of the equation by 6 raised to the power x minus 2. Equivalent to 6 raised to the power x minus 2 times the quantity 6 raised to the power x plus 1 plus 6 raised to the power x minus 1 plus 6 raised to the power x equals 6 raised to the power x minus 2 times 43 over 6 raised to the power x minus 2. Eliminating parentheses and applying the distributive property of multiplication over addition. Equivalent to 6 raised to the power x minus 2 times 6 raised to the power x plus 1 plus 6 raised to the power x minus 2 times 6 raised to the power x minus 1 plus 6 raised to the power x minus 2 times 6 raised to the power x equals 43. Using the product property for exponents, to multiply powers of the same base, keep the base, 6 in this case, add the exponents. Equivalent to 6 raised to the power 2x minus 1 plus 6 raised to the power 2x minus 3 plus 6 raised to the power 2x minus 2 equals 43. On the left side of the equation, factor the GCF. Equivalent to 6 raised to the power 2x minus 3. To factor means to divide every term by the GCF. Keep the base, subtract the exponents. So, in this case, 6 raised to the power 2x minus 1 divided by 6 raised to the power 2x minus 3 equals 6 squared. Then 6 raised to the power 2x minus 3 divided by 6 raised to the power 2x minus 3 equals 1. So we write plus 1. And then 6 raised to the power 2x minus 2 divided by 6 raised to the power 2x minus 3 is 6 to the 1. So plus 6 to the 1, which equals 43. Perform addition inside the parentheses. Equivalent to 6 raised to the power 2x minus 3 times 43 equals 43. Divide both sides of the equation by 43, equivalent to 6 raised to the power 2x minus 3 equals 1. writing 1 as an exponent, equivalent to 6 raised to the power 2x minus 3 equals 6 to the 0. The exponential function f, where f of x is equal to 6 raised to the power x, is a one-to-one function. Thus, we can rewrite this statement as f of 2x minus 3 equals f of 0. We can remove the function without losing or gaining solutions. So that's equivalent to 2x minus 3 equals 0. Equivalent to 2x equals 3, divide both sides by 2, and we get equivalent to x equals 1.5, which belongs to the domain. Thus, the set of solutions is the value 1.5. We created the same base, and we used one-to-one functions to solve exponential equations. The end.